Good morning, class 6. Today we'll be doing part 2 video of lesson number 13, light, shadows and reflection. Let us recall what we have learned in the first video. We learned that light is a form of energy. We need light to see things. It is essential that light is present in order to see things. In a dark room, we cannot see. Luminous objects are objects that emit light or they give out light. Non-luminous objects are objects that do not emit light. Objects can be transparent, translucent or opaque depending on how much light they allow to pass through them. Transparent objects allow light to completely pass through them. Translucent objects allow some light to pass through them, and opaque objects do not allow any light to pass through them. Shadows are formed by opaque objects. They are dark outline of the objects. These are the things which we learnt in part 1 video. Do you see this beautiful picture? What do you think this picture is? Yes, it is a solar eclipse. It is a beautiful picture, isn't it? But what is this picture to do with light or shadows? You will be surprised to know that the eclipses that are formed, be it the solar eclipse or the lunar eclipse, are in fact formed due to shadows. Shadows which are formed by objects in the sky like the sun, the moon and the earth. Let us now understand how solar eclipse is formed. So shadows in space is nothing but an eclipse. Shadows formed by giant heavenly objects is nothing but an eclipse. How is a solar eclipse formed? For any eclipse to form, all the three bodies, namely the sun, the moon and the earth, should be in a straight line. This occurs on either the new moon day or the full moon day, right? For a solar eclipse to be formed, the moon should cast a shadow on the sun so that partially, say it is able to cover only part of it or fully, and we are not able to see the sun. Okay, so this is what is an eclipse. But you may ask a question, how such a tiny moon is able to cover the full of sun, which is much bigger. This is possible because the moon is very near to us. Let us now understand how a lunar eclipse is formed. Again, for a lunar eclipse to be formed, the sun, the earth and the moon, all the three should be in a straight line. This time it is the earth which casts a shadow on the moon and we are unable to see the moon. Most of the lunar eclipse occurs during a full moon day, and because of the shadow of the earth falling on the moon, we are unable to see it and we call it the lunar eclipse. Now, we already saw that light travels, right, through space. We need something to represent this light, to show the movement of light, since we cannot actually see the light, isn't it? So we use representatives such as rays and beams. The above picture, that green arrow represents a ray of light. Okay, it starts with a point which tells it the starting point of the light, and the arrow indicates direction of the light. Just below it you can see three other pictures. You see they are parallel beams. So many rays are there which are parallel to each other. We call it as a parallel beam. If these rays of light appear to be coming from a point, then we call it as a divergent beam. Like the torch light, the light coming out from the torch, from the single bulb, it spreads in a conical manner, isn't it? So that it is a divergent beam. The last diagram represents a converging beam. So light from different directions converging or meeting at a point. This is called a convergent beam. So as the rays and the beam suggested, light travels in a straight line. This is a very important property of light. Light always travels in a straight line. How can you prove it? Yes, look at this boy. What is he? What is there in his hand? He has a long tube. Okay, he uses this tube to see a lighted candle. In the first case, when the tube is straight, he is able to see the candle. Then what he does, he slightly bends the tube and now tries to see the candle. In the second instance, he is unable to see the candle. Why? Since light travels in a straight line, so from a bent tube, we cannot see light. This property of light that it travels in a straight line, we have a name for it. We call this as rectilinear propagation of light. Here is another small experiment which you can even try at home to prove that light travels in a straight line. What we have done in this experiment, we have taken 3 cardboard pieces, rectangular cardboard pieces of same size, and we have made a hole in the center at the same place. Okay, and then we have arranged these cardboard pieces A, B, C, one after the other, so that all the holes are in a straight line. Now, on one side of this cardboard, we have put a lighted candle, and from the other side, we try to see the candle. Do you think we can see it? Yes, of course we can see it, because A, B and C cardboards have holes in a straight line. So in the first case, we are able to see it. Now, move the cardboard B a little towards the other side. And now try again to see the candle. This time you won't be able to see the candle. Why? Because the holes are not in a straight line. The second property of light that we are going to study is reflection of light. What do you understand by reflection of light? Have you ever played with a ball? Have you tried to bounce the ball on the ground? What happens when you forcefully put the ball on the ground? It bounces right back, isn't it? This is what happens when light falls on an object. It bounces back. This is called as reflection of light. See the left hand side picture. What do you see? If the surface is irregular, when the beams of light fall on it, they bounce back in different directions. We call this reflection as diffuse reflection. Take a look at the second picture. When there's a smooth surface like a glass or a tiled surface, what happens when the beam of light strikes it? It bounces back evenly. It gets reflected evenly. This type of reflection is called a regular reflection. What happens if you put a beam of light on a mirror? Yeah, it bounces back and you see a regular reflection, right? And the angle at which the beam falls on the mirror is the same as the angle at which it gets reflected. We call this as angle of incidence and angle of reflection. So what is a mirror? What do you see that boy doing? He is standing in front of a mirror. So the boy now is called the object. Okay, instead of the boy, you can put a tree, you can put a pencil, you can stand yourself, and you will be called the object. What you see in the mirror is the image. It's an exact picture of this boy being shown in the mirror. Okay, this is called as an image. So, when you stand in front of the mirror, what do you see? You see an image. But what exactly is a mirror and why do you see an image in it? Okay, let us understand what is a mirror. A mirror is nothing but a plain glass, on the back side of which it is painted with silver paint. So we have a total reflection. Okay, all the light that passes through it gets reflected back. Since it's such a shiny surface, a very regular type of reflection takes place, resulting in the formation of a mirror. This is the reason why we said that mirror is not a transparent object but is in fact a translucent object. So I hope you have understood what is an image. So image is the picture that is formed due to the reflection of light. So not only mirrors, any shiny surface like a new steel plate or a steel vessel or a steel spoon or why even water will form an image. You see the water there, that lake showing the reflection of all the trees and the buildings which are nearby in the water, right? So this is how the image is formed in a plane mirror. In the center you see there is a plane mirror. On the left hand side the man is standing, he is the object. The light travels, it gets reflected back, but what you see actually, it appears as if there is an image formed right behind the mirror. So the image appears to be present behind the mirror. So here are some words which are commonly used to describe an image. They always work in pairs. We'll see what these words are and then one by one I'll explain to you what they actually mean. So the first pair of words that describe an image is real image and virtual image. A real image and a virtual image. An image which is upright, straight and inverted. Inverted means upside down. An enlarged image and a diminished image, or it could also be of the same size. Enlarged means the object is small but the image is bigger than the object. Okay, a diminished image means the object is big but its image is smaller. Then we call the image as diminished, or the image also could be same size as we see in the plane mirror. Now let us understand each of these words with the help of some pictures. So what is a real image? An image which can be obtained on a screen is called a real image. You see this picture of a tree, the object is towards your right, and what you see the image, you can obtain it on a cardboard box which is painted white. So that white cardboard box becomes the screen. Right? So a screen could be a piece of cloth, it could be the ground, it could be a wall, it could be anything. Right? This is called a screen. So when we are able to obtain the image on a screen, we call it a real. Look at the right hand side picture. What do you see? A man standing in front of the mirror. Okay. So this is a virtual image. Okay, you're not actually able to touch the image or get it on a screen. The image appears to be coming from inside the mirror, isn't it? So this type of image is called as a virtual image. Let us take the next pair of words, enlarged image. See the lady on the left. How is her hand looking? It appears big, isn't it? So that type of image which is larger than the object is called an enlarged image. Look at the man seeing a mirror on the right hand side. Okay. The image of the man appears to be smaller than the man himself. Then we call this image as diminished. Or it can be of the same size, what the plain mirrors that you see at home daily, isn't it? That in that you see the object and the image are of the same size. Upright versus inverted. So you see the small boy looking at the mirror. How do you see? The image is upright, standing straight, just like the boy. Look at the image formed by this pinhole camera on the right hand side of the tree. How it is? The image is actually upside down. It is not upright, but it is upside down. Then we call this image as inverted image. Now, using these words that we have learnt, let us understand the image formed by a plane mirror. What is a plane mirror? The mirror which you see daily in your house while brushing, okay, while getting dressed, while combing your hair, that is a plane mirror. That is in fact a plane mirror. So, how is the image formed in a plane mirror? So, what were the terms that we learnt? Erect and inverted. So, what is the image that is formed by a plane mirror? It is always erect, isn't it? Standing upright. Is it real or virtual? It is virtual because we cannot obtain this on a screen. What about the size? Is it diminished? It is enlarged, or it is the same size? It is of the same size as the object. What about the distance from the mirror? Okay, so a boy is standing 2 feet from the mirror. How far will the image be formed from the mirror? About the same distance, 2 feet only. So, the same distance as the object from the mirror. Right? Now, look at the interesting thing. Can you read the words on the boy's t-shirt from his image? Can you? You cannot. Why? Because it is inverted. It is laterally inverted. It means the left appears as right and the right appears as left. It's an interesting thing. When you stand in front of the mirror, your right hand will appear as your left hand and the left hand will appear as right. What do we call this phenomena? We call this as lateral inversion or laterally inverted image. Let us now understand the difference between shadows and image. A shadow is always dark, isn't it? No matter how the light is, the shadow is always going to be dark. But the image is exact replica or a picture of the object itself. It shows you details, isn't it? If you are wearing a red dress, your image will also show a red dress, isn't it? How is a shadow formed? A shadow is formed due to obstruction of light because light is not being allowed to pass. Light is being obstructed. That is why a shadow is formed. Why an image is formed? An image is formed due to reflection of light. Light is being reflected back from a surface. That is why an image is formed there. Let us come to the last portion of our lesson today, the pinhole camera. Listen carefully because this is also going to be your project work for this lesson. You have to make a pinhole camera and upload the pictures. So listen please carefully how to make it. What you'll need for this, you will need 2 rectangular boxes. You can take shoe boxes or you can take 2 different sizes of toothpaste boxes. They are very ideal. Okay, if you're not able to find any of these, you can just roll a piece of cardboard into cylinders and you can use that also. How should these 2 boxes should be? One should be smaller and should slide into the other. So the brown box on your left is little bit bigger and the green one on your right side is little bit smaller. Okay. Now what you do, first thing you do is you cut open one side of both the boxes, the big box as well as the small box. On the bigger box, on that side, the other side which is still there, you make a small pin hole. I mean to say a pin hole. Don't make a big hole. It should be a pin hole, a very small hole. On the smaller box, you cut open a small piece of cardboard right in the center and stick a paper, a butter paper. If you get a butter paper, well and good. Otherwise, a white paper you can stick. Right? Now slide in, once this is done, slide in the smaller box into the bigger box. Okay. Now focus on a far off object like a electric pole or a tree, and keep moving the box, the inner box, and get the image on the butter paper or the screen. Right? This is what you have to do. Now, how is the image formed by a pinhole camera? This whole setup, we call it as a pinhole camera. Okay. So, how is the image formed by a pinhole camera? Right? The image you see is not erect, but is inverted. You are able to get it on the screen, that is that butter paper, isn't it? So, what type of image is it? Real or virtual? Since we are able to obtain it on a screen, we call this image as a real image. So the image formed by a pinhole camera is a real and inverted image. Do this interesting activity and upload your pictures on my personal number. With this, we come to the end of this lesson. Hope you enjoyed this new lesson. Bye bye and take care.